Three-flute end mills dominate aluminum machining, and rightly so. They're versatile and commonly available, but when would you choose something else? This is a common question. A lot of shops when machining aluminum default to three-flute end mills. Nearly all of the time they work great, but there are real limits and more variables than people think. Not taking these into consideration could cost your shop in various ways. In this video, we're going to look into where three-flutes shine and where they struggle, and how your tool choice should change depending on the part geometry, chip load, machine power, and more. Let's get into it. So why are three-flute end mills so common in aluminum machining? Well, they hit a sweet spot. You get better rigidity than a two-flute, but more chip clearance than a four-flute. That balance makes them ideal for most applications, including pocketing, profiling, and finishing in aluminum alloys such as 6061 or 7075. Three cutting edges also mean you can feed faster without overloading the tool, though there are a few variables here which we'll talk about later in this discussion. With three-flute end mills, you also get smoother cuts, less chatter, and better finishes. It's no surprise that they've become the go-to in a lot of shops. But that doesn't mean two-flutes are outdated. With fewer flutes, you get larger gullets, and in aluminum, chip evacuation is everything. If you're cutting a deep slot, doing heavy roughing, running into tight corners, or running a machine that doesn't have the best rigidity or power, a two-flute end mill may be the better choice. Also, if you're machining a thin-walled or floored part, a two-flute tool will generate less pull or grab on the component as the chip is formed. As mentioned earlier, where three-flutes really shine is their versatility in both roughing and finishing operations. That extra cutting edge balances the tool load better, reduces deflection, and helps improve your surface finish, especially on shallow passes, either radially or axially. But there's more to it than just the flute count. Coatings or polished flutes, corner radius, and chip breakers can really make a big difference in tool performance, and it sets up why we need to question our habits and assumptions. Because we've always done it that way is usually why a three-flute end mill is chosen when machining aluminum. People assume that there are no better options, and that's where you may not be getting the best solution for your application. If you've ever had aluminum weld to your cutter or seen a finish come out worse than expected, what we discuss next could save you cycle time and your tooling budget. Let's look at the most common reasons machinists run into trouble when using a three-flute tool. There are a few common situations where a three-flute tools may have issues, especially when machining aggressively. Deep slotting, you may experience chip evacuation issues due to longer chips and the slot width. Heavy roughing, you may see tool deflection or breakage. Are you running operations on a low-powered or less rigid machine? The added flute pressure could overwhelm it compared to using a two-flute end mill. Most three-flute aluminum-specific end mills on the market also only have one flute cutting to center. This significantly limits the plunging and capability as well as the balance and achievable surface finish. However, tools like the SGS S-Carb have all three flutes cutting to center, giving it exceptional balance and plunging as well as floor finish capability. Tool choice is just one piece of the puzzle though. Your machine matters too. Machining aluminum requires high RPM even with larger diameter tools, and chip loads are far heavier than other materials. Although machining aluminum is generally considered easier than most, you'll still need a machine with a good level of rigidity and RPM capability. And as always, good coolant is crucial when cutting aggressively or at high speeds. Getting coolant to the cutting zone is critical for improving chip evacuation and tool life. Through spindle coolant offers even more advantages, but we'll get into that detail shortly. Now let's talk economics for a second. Aluminum tools are known to last for hours of cutting, but tool cost and life should still be considered, especially when machining a high volume of parts. Key areas to consider with tool life is the distribution of wear across the number of flutes. Generally, a two-flute will wear out quicker than a three-flute, and in theory a four-flute should last longer provided they're all carrying out the same operation and same parameters. Due to aluminum's machinability, radial engagement isn't really a concern in terms of the tool capability. It's more of the part geometry and fixturing that create instability and chatter during heavy engagement. Of course, this can be compensated for by refining the parameters. Axial depth of cut should be considered too. Taking a big chip is one thing, but making it 2 times D of the tool or longer, and you could start having issues with chip evacuation or nesting. If you're wanting to take a long axial cut, consider using a tool with a chip breaker to cut those chips down and make them easier to evacuate and reduce the spindle load. As previously mentioned, chip control is vital in aluminum machining. You're creating a lot of chips very quickly, and if they cannot be effectively evacuated, you're going to have issues with them recutting. This is going to cause issues with your tool life and the surface finish of your component. Always try to have some form of coolant flow or air blast to assist in clearing away those chips, especially when slotting or working in deep pockets. Flood coolant is a great way of getting those chips washed away, as well as increasing the lubrication and controlling the temperature of the cutting area. High pressure coolant works extremely well at getting those chips cleared too, especially if the tool you're using has through-tooled coolant holes. So what if you need more from your tools while machining aluminum? Well, try considering even more flutes. Four-flute options built to take advantage of big, high-speed machines producing large aluminum components as quickly and efficiently as possible. These tools are made to run fast, and by fast I mean 20,000 RPM or more. They are not for everyone, but in the right application they can significantly improve cycle time and surface finish. So why are 3-flute end mills in aluminum so popular? Well, to be honest, they work in 99% of aluminum applications, whether aggressively roughing, pocketing or finishing. They offer balance, speed and versatility. But don't forget 2-flute options can run very aggressively while maintaining tool life, and if you have the performance and capabilities, there's always the 4-flute options. Remember, the tool is part of a system. Pick a tool that works for your setup, application and part. Thanks for joining us today on Tips and Chips. If you found this helpful, like and subscribe and hit that notification bell. Do you have any questions or tips to share? Please leave us a comment below. We'd love to hear from you. Do you need any help? Visit the links in the description for even more resources. And, as always, keep those chips flying.